Hi guys, this is Mudupi the Genius, your tutor from Genius Tuition Institute, and today this lesson is going to concern the grade 11s and the grade 12s. During this lockdown, I would like all of you guys to focus on achieving the impossible. Some are saying it is impossible to make it this year. But I am saying to you, we are going to make it willy-nilly. So, guys, today I want us to focus on functions. What are functions? Functions are graphs. Graphs. We have linear graphs, quadratics, functions. Now in trigonometry, we have all the trigonometric functions. Look, when we talk about trigonometry, I just want to show you something. When you look here, you will get sine, this is cos, and that is tangent. Now, those are trigonometric ratios. Now, we are going to make functions using sine, cos, and tangent. And that's it, guys. So, how are we going to do that? First and foremost, we know that we must have, in order to plot a graph, we must have the x as well as the y-axis. That means we must have our grid or our plane. So our x plane will take the degrees, whereas the y will take the distance, that is the height of a particular wave. What are we going to discuss here? Entails waves, guys. Trigonometric functions are wave graphs. Let me show you a practical example. Sound travels in waves. You may have transversal waves and longitudinal waves. So these waves have their own height, the maximum height, and the maximum, the minimum, the absolute minimum to reach. That is where we call, that is the range from the lowest to the highest point. That is the range of that wave. And that is determined by the y. So guys, how are these essential in our daily lives? Point number one, we use cell phones. Sometimes when you call somebody, you will hear him saying, I can't hear you properly. Why? Because of the wavelengths. Now, the wavelength is the height of is the distance traveled by the wave in order to reach its maximum or minimum. That is lambda in physics. It's lambda. So, guys, now we are going to start with a sine graph. Sine graph. Now, another example, I nearly forgot to tell you this. When you go to a hospital, any hospital, there is a room. There's a room that everyone hates. It's called I see you. No, it's called ICU. That is intensive care unit. Intensive. They care for you intensively. By using what? By using the machines. That is technology. Now, you will see some screens there. There will be some waves, some graphs there. And if that graphs forms waves, we know something, that it tells you something. Graphs will tell you something, guys. Those are trigonometric graphs, guys. It will move like up and down, up and down. And what happens when it forms a straight line? It also tells you something. And that is a very sad story. When it goes up and down, it tells you that the person is alive. Why? Because that is the heartbeat makes those waves, the up and down movement. And when it is flat, that is, it is horizontal, there is no up and down movement, we know exactly that we are now having a sad story. The person is no longer alive. Now, this is where trigonometry comes in, guys. Now, some of you will say, these things, we learn this from school, but they are not possible to realize in real life. Yes, guys, this is because we don't teach you that. So, Tubes the Genius is going to teach you reality. So let's do it. Let's do it. Fine. Sine graph. Trigonometric functions. And then we start first with the sine graph. Now, in any function, there are standard rules, guys. In any environment that you enter into, there are standard policies, there are standard rules set. Now, for any sine graph, you will have it in the standard form. That is y is equal to a sine bx, where a is the numerical coefficient of the whole function and b is the coefficient of x. Now, what is a? A tells you more about the movement of the wave. That is the up and down movement of the wave. And it tells you the maximum as well as the minimum. Now, up and down, that is along the y-axis. If we will reach the maximum and the minimum, we call that the range. And within that particular range, there is a distance. And that distance is called the amplitude. Amplitude. In science, it is called lambda. So guys, let's begin. Let the story unfold. Right here, we are having features that we need to follow. As I told you that in mathematics, we follow mathematical principles. If you don't abide by those principles, you're doing your own stuff. And you're not going to get it right. So here are the features, guys. Point number one, you have to determine the domain. Now, in this case, Say, for an example, it is given that our x is an element of real numbers. You have to understand that element of real numbers is any number. Any real number, not any number. We need to be very careful when we talk. Not any number. Real, all real numbers. This is called the domain. The domain entails all possible x values pertaining in this graph. And then all possible y values which are determined by this. It's called the range. We have the range as well as the domain. Now let's get to the next feature. The next feature is the range. Now, as I told you guys, that the range is determined by A. The range is Y is an element of, you always start with a small number. This is a square bracket. That means it is included. You start from negative A up to positive A and then close square bracket. Now these points are included in the decision making, that is in the drawing of the graph. So guys, now we move to the next. The intercepts with the axis. That means the intercept with the y as well as the x-axis. Let us start first with the y-intercept. We know from linear graphs, all those graphs, that is the parabolas and the hyperbolas, that when you want to find the y-intercept, always substitute by 0. So we substitute them with 0, and then for the x-intercept, you always substitute y by 0. But in this case, I'm going to show you something. You are going to do this. You are going to substitute by 0, 180, and 360. Those points, when you look at your a compass, a 360 degrees compass, you'll find that all these points are on that straight line. That is 0, 180, and 360. They are on a straight line. They lie horizontally. So next, we get the turning point. Now for the turning point, you always get, look at this. We have bx. In order to find the turning point, you have to concentrate on bx. Bx, that is an angle. B is the numerical coefficient of the reference angle. So what happens here? You take that and equate to, because the sine graph turns at 90 and 270. So you equate that to 90. Bx equals 90, then you solve for x, which is your reference angle. That is the angle that you refer this diagram to. So that will be 90 and 270. That is the turning points. Now, x will be equal to 90 divided by b, and it will also be equal to 270 divided by b. Now, therefore, the turning points will be, remember, you still remember that I told you that this will determine your maximum as well as your minimum. Your minimum is always less than the maximum. Therefore, we take a negative and a positive. So for the turning point, because your A, if your A is positive, is going to move upwards. We will, with this, the first turning point at 90 will be positive. But if the function is negative, that is your a is negative, then we are going to get here, we are going to get a negative because you'll be having a negative. Look, this is positive, positive. But if it was negative, this is going to come here, we'll have negative, and then you are going to have a positive there. It will just change. So guys, these are the turning points. 90 divided by b. If b was 2, if b was 2, it will be 90 divided by 2. That will give you 45 is to a. And if a was 3, then it will be 45 is to 3. And here it will be half, is 135 is to minus 3. That will be it. But now we have to move to the next. Let us check. I told you about the range. Now the range, as I've said, is minus a and is up to a. Now our range is always, now those who do physics will know all about this. This is the absolute value that determines the distance. So the absolute value, if you go deep underground, we cannot say you went negative 260 kilometers. The negative it tells you the direction. So the absolute value of a, if our a was 3, the absolute value of 3 is 3. If it was minus 3, the distance that you will have covered will be positive 3. Therefore, the amplitude is never negative, guys. You just, if you have a negative a, you ignore the negative, and that is a. If it's positive 3, positive a, then you just put it as it is. So that will be the amplitude. Now the amplitude is the wavelength. So guys, another thing, this in physics is called frequency. Frequency, or the period. Period, in mathematics we normally say period, but mathematics and physics goes hand in glove. So when I talk about the period, I talk about the frequency. How frequent will that wave happen or occur? This, you get this by dividing 360 by b, which is the numerical coefficient of x. Because this happens within a circle, within a revolution. So waves are revolutionary. That is why we have a wave. When a wave occurs, you drop something. As I told you that they are in a form of, they are circular. Then how do you do that? Take a stone, drop it in water. What will you see? You'll see some ripples, circular ripples, and they are circular. No fault, no curves, circular, guys. So this is it. Now, how frequent will a wave happen? Now, this tells you that it will happen that is why you see some ripples. A wave, when a wave happens. That is because of the period. From one, because what you see is the top of the wave, when water forms ripples. Then from one point to the other, that is a wave. That is a wave. So what is the frequency? How frequent will that wave occur? You just take for sine and its counterpart, that is its cofunction, which is cosine. That we will deal with that later. Their frequency, or their period, is 360 over b. whereas of the tangent, you just divide that by half, and that will be 180 divided by b. That is the frequency. So guys, let's move on. Let's move on. Now, these are all the features. I will repeat this feature. The first one is the domain, and the second is the range, and then intercept with both axes. When you draw the graph, you need to know all this 6 stuff. Okay, guys. So let's get to the next page. Now, the next page is where we are going to be hands-on on the graphs. Let me give you this. Yeah, practical sketching. This is when you do the sketches. It says, draw the graph, draw y is equal to sine x. I wrote that one there to show you that if there is no digit attached to x, it's 1. Then our a, what is our a and b? Our a is 2, that is positive, and then our b is 1. Thank you. Now, features, the amplitude. Let's start with the amplitude. The amplitude is determined by a. This is 2. Amplitude is never negative. That is why it is inserted in the absolute values, so that it is not negative. So this will be equal to 2. Our amplitude, our wavelength will be equal to 2, and then the frequency. The frequency will be equal to 360 over b. What is our b? Our b is 1. Now that is 360 degrees. Degrees, guys. Sorry. Degrees. Then that will be 360. What does this tell us? It tells us that after each and every 360 degrees, a new wave is going to form. A new wave is going to form. If it is a signal transmitter from maybe Telkom or Vodacom or MTN, using this function, a new wave is going to form after 360 degrees. And the amplitude, if this determines the meters, if this is 2 kilometers from the point of transmission, then anyone who's 5 kilometers above that will never reach the signal. That is why you will hear somebody say, no, I can't hear you. Go and stand somewhere at the top of the hill, or go and stand somewhere. That is when you can reach the signal. Sometimes there are some obstacles along the way. That is why the signal can reach you. So this is it, guys. Now, another thing is, how do we determine the range? The range is a parameter within which that particular wave is going to run. It's like a tube. A tube. If you have a 20 millimeter tube, then that range, that is the range within which the water will run. So our range here is -20. We always start with a smaller number from the least to the greatest. That is y. The range is always determined by y. y is an element of, okay, y is an element of -2 up to 2, then close. That is square bracket. Now for the square bracket, if you use the square bracket here, guys, it means -2 is part of it. But if you use just ordinary brackets, that means -2 is not part of that. -2 and 2 are not part of that. That is why we draw a blob or an open dot at that particular point. It's called a blob, guys. Blob, B-L-O-B. Fine. Now, the next is the domain. The domain, guys, look at this. This specifies exactly what they need. You have to draw this function within this domain from 0 up to 360 degrees. That's it, within that range. If you draw it from 0 up to 180, it's wrong. The first thing that you do, you read this to understand. Remember, our strategy, guys, in mathematics, my strategy and our strategy, dupes the genius, don't forget. We use USA. Mathematics needs that. I realize that. That is the concept that I use. USA. U stands for understanding. S stands for speed. A, which is the very important one, is accuracy. Accuracy. Whatever you do, you have to understand it first. That is why I say, draw, you must read this. Draw y is equal to sin x, where this is equal to. You have to understand the entire meaning of the whole thing. Don't just take part of it, draw the graph. What do you normally do, guys? I know you just read here. You don't read that. Draw y is equal to 2 sin x. And then it seems as if you don't see this. Guys, don't do that. Read the whole thing. Anything that is written on the question paper is important. If it was less important, it couldn't have been there. So this is it, guys. So let's move. Now the domain is that, then the intercept. For the intercept, you let x is equal to 0, 180, and 360. And then in this case, we have that. That is y is equal to sin. Y is equal to sin. We substitute here by, yes, we substitute here x by 0, then x here by 180, and x there by 360. Now let us check that. I just want to punch on this. Yeah, let's use this. Let's start with this one. It's 2. Okay, let me just do this. Yeah, it's 2 sin. 2 sin, then I just want to check whether is it no. Yeah, it's 2 sin 0, close bracket, that. And the answer gives us 0. It gives us 0. I'm sorry, it's flickering, guys. But anyway, you see that. Then, let's change this. Let's change this to 180. Press 180, and then it gives me 0 again. And then let me go change that. 360. 360. 0. Now, that is why we got this, guys. Y is equal to 0. Now, therefore, the point here, that is the y-intercept, it will be 0, No, the x-intercept, guys. The x-intercept, it will be, the y-intercept, it will be, this is the x-intercept, guys. 0 is to 0, and then 180 is to 0, and then 360 is to 0. Right. Now let's move to the turning point. The turning point, remember, this is going to be the y-intercept as well as the x-intercept. This one. Now, for the turning point, how do we get the turning point? Guys, we said that for the turning point is always 90 over b. That is 90 over 1. Our b is 1. Then is to 2. This is 90 is to 2. And then this is 270 is to 2. So this is all the features. Now, the next point is we are now going to draw the graph. We are now going to draw the graph. I just want to show you this, guys. This is the sketch. This is the sketch of that. 0 is to 0, then we had 90 is to 2, and then we had 180 is to 0. These are the x-intercepts. And then this is also the y-intercept. If you put this x is 0, then you get that. Now for all the y-intercept, you get this. You are going to change this to 0, and then just like you do in algebra, guys. So these are all the x-intercepts, and this is the only one y-intercept. Now, let us look at the turning point. This is 90 at the highest point. This is the turning point. It turns. It turns at the maximum and the minimum. Now, this will be our maximum. It looks like a mountain. This one, it looks like a donga or a river. Therefore, this will be the minimum. Now, if they ask you, what is the maximum of the graph? The maximum will be at 2. You take the y value. What is the minimum? The minimum will be at minus 2. Now, the question may also arise, for which values of x will this graph have the maximum? It will be at 90 degrees. For which values of x will that have a minimum? It is at at 270. Now this is the sine graph, and this is a complete wave. Look, we said the amplitude is from here to there. This is the wavelength, guys. And look at this. This is also the wavelength. The distance from here to here is 1, 2. Distance from there is 1, 2. Therefore, the distance is the same. And look at this. It's 90, 180, 270, 360. This is half a wave, and this is another half a wave. Therefore, this is a full wave. It has the upper part and the lower part. So a wave, if you see the ripples in water doing like this, then you have the upper part and the lower part. So this is it, guys. So another thing that we need to do, guys, I need you to do this. You are going to draw the graphs of the following on the same set of axes. The first one is y is equal to 3 sine 2x. And the second is y is equal to 2 sine 3x. You write all the features of each and every graph. I want you to know that, guys. So, in order to be successful in mathematics, guys, you need to be proactive. Listen to your conscience and do what your conscience says, as long as it is for the benefit of your future. USA, don't forget, is understanding, speed, and accuracy. And the last part is triple check. Never go out of the examination center without having triple checked your script. Never write and then submit the script. You check it for the first time, and then what do? If you get some mistakes, rectify them, go for the second time, do the same, and then lastly, you will know that everything that you wrote there is up to your satisfaction. So guys, if you do maths, math has value. So I would like to say thank you for everything, guys. Thank you. And make sure that you pass. Thank you.